Welcome back to part 2 of our lesson on transformation of sinusoidal functions. Really, yesterday we saw everything there is to do for transforming a sinusoidal function. We saw that we could move it up and down, left and right. We could squish it or stretch it up and down, and we could squish it or stretch it horizontally as well. So now we're going to just put all of those together into one big equation. So this wonderful equation here is what all of our trig modeling will look like. And each of the pieces we've dealt with independently. We've just never put all four together at the same time. So the first thing we looked at was moving up and down. That was the plus and C. Sorry, plus C. I don't know what plus and C is. Plus C. The minus D part was the moving left to right. Again, remember that when D is positive, so you have X minus a number, it's going to move to the right. And when D is negative, you have X minus a negative is X plus a number, moves to the left. The A in the front stretches or squishes up and down. We're not going to worry about the negative because we don't need to. And finally, we talked about a K value, but I'm going to get you to always write it in the form of 360 over the period because it's much easier when we're modeling, first of all, to write down what the period is. And also when we're trying to read that to try and figure out what's going on in the function, it's much easier to read the period off instead of having to do a calculation to get it. Okay, I'm going to make one note that we haven't kind of dealt with yet, although I've hinted at it a few times, and that's the importance of, just get rid of this excess highlighting here, the importance of this x minus d being in brackets. And it's because we want the d, the shift side to side, to also be affected by that k value or the 360 over t. If you don't put the bracket around there, it won't be affected by it. So that bracket is very important to remember. Okay, so let's take a look at a function and see if we can actually just do this. So unfortunately, I'm going to make this just a little wee bit smaller so I can fit everything on my screen at once. And we're just going to fill in this table. So the first thing we want to do is figure out what the amplitude is. And by the way, sometimes the order of these really doesn't matter. You do whatever order you want, but I'm going to do them in this order. So the amplitude, well, we take a look at where the max and the minimum are, and we look at the distance between them. And the distance between them goes from positive 17 to negative 7. That's 24 from the top to the bottom. But remember, that's actually two amplitudes. 24 is the distance above the rest position to the max, plus the distance from the rest position down to the min. So the actual value for it is going to be 12. Now, if you're somebody who likes formal mathematics, you could do this as max minus min divided by 2. So it's the difference between the maximum and minimum divided by 2. In this case, that's 17 minus negative 7 over 2, which is 24 over 2, which is 12. Okay, the period. The period, we just look at where the peaks are. So we have a peak here at 2, and the next peak is at 14. And we say the distance between them then is just 12. So distance between the peaks. Now in this case, it is also 12. I didn't do that on purpose. That's just kind of a coincidence. Here's an interesting thing that happens though sometimes. I'm going to make a mess of my graph for a second. You don't have to follow suit with me, but I'm going to pretend that this part of the graph is not visible. We don't have that. Well, then what I could do is say, how am I supposed to find the distance between two peaks? And I can't. But what I could do is find the distance between the peak and the minimum over here, which is at 8. And I can say, how far are those apart? And those look like they're 6 apart. Well, the distance from the max to the min is 6, but the distance from the min back to the next max is also 6, so I could just double the 6 and get 12. So if you don't have an entire piece of graph where you can go peak to peak, You could also go trough to trough, or the minimum to the next minimum, because they should be the same distance apart. But if you have one max and one min and you can see how far apart they are, that's going to take you through half a cycle. So basically, the half cycle takes us from top to bottom. The next half would take us from bottom to top. So there are a couple different tricks you can do and ways that you can calculate that. All right, I'm going to get rid of this extra stuff here because I don't think we need it anymore. There we go. The horizontal shift, again, this one's pretty easy to find. It's just the location of the first peak. And the first peak appears up there at 2. So I'm just going to put down 2. Now, I should be clear. When I'm actually modeling this, I can use any of the peaks. So I could do that the horizontal shift is 14 over here. It's just, if we do that, there's going to be an infinite number of possible answers. And it's always just easiest to choose the first peak and go with it. And then we've got the vertical shift. How far up did it go? So there's a couple of ways that you can find this. And this, again, this is why we don't use sign to model. It's hard to say where the rest position is. Is it there? Is it here? Is it somewhere around there? I can't really tell. But what I will say is that if we know what our amplitude is, our amplitude's 12, the peak is 12 above the rest position. Well, 12 below the peak will take us down to 5. And 12 above the minimum will also take us to 5. So we can either do the max minus the amplitude or the min plus the amplitude. Or if you can just look at it and say, what's the average of the two numbers? Max plus min divided by 2. Notice that that's plus, whereas the amplitude was max minus the min divided by 2. But if you take the two values and take the average of them, the average of the max and the min will be the halfway point between them. Either way, for our particular one, that's going to be 5. That's not too bad. All right, let's just write the equation for this since we've got all the information we need here. So f at x equals a, so that's 12, cos, and then I do 360 divided by period, which is 360 divided by 12. Then I remember my bracket around the x minus d part. So d is 2, so this is x minus 2. And then finally it's shifted up 5, so plus 5. So that's all there is to these, really. You don't have to set up a full table every time. You can just look at it, write down any little calculations you need to write down, but it's essentially finding those 4 values, the amplitude, the period, the horizontal shift, and the vertical shift, and then throwing them into our somewhat ugly looking general equation, but it's actually pretty easy to use. It's always going to be the same format. All right. Let's try this again fairly quickly with just these couple of more examples, and then I'll let you practice this on your own. And the good news is when you're practicing on your own, you can always put your suspected answer into Desmos, see if it works, and then if it doesn't, you can see if you can figure out where you went wrong. Okay, so this one, I'm not going to do all the calculations. I'm not going to make a table. I'm just going to write down f at x equals and start writing down values I know. Okay, so the amplitude. Well, we're going from 0 up to 78. Sorry, we're going from 30 to 78. That's 48 from top to bottom. And amplitude is half of that, so amplitude is going to be 24. Cos. 360 divided by the period. The period goes, there's a minimum at 0. The next minimum is at 12, so the period's 12. The first peak is at 6, so that's going to be x minus 6. And halfway between the max and the minimum is either 78 minus 24 or 30 plus 24. Either way, it's plus 54. That wasn't too hard. Okay, one more. The amplitude, the distance from the maximum to the minimum. Now this one, the numbers are kind of cruddy, so I might use my calculator. But I'm going to do the maximum is 15.135. Subtract the minimum, which is 9.02. And those are 6.115 apart. And so the amplitude will be half of that, which is going to be 3.0575. Now, only because I'm working with very precise numbers on the graph am I going to bother writing that down. 3.06 is probably more than accurate enough, but we have the exact value, so we might as well. All right, then the next part is to find the period. And I know that we have a peak here at 172 and a trough or a minimum at 355. So 355 minus 172 is 183. But since that's from max to a min, not a max to a max, I have to double it. So double that times 2 takes us to 366. The first peak is at 172, so I'll just do x minus 172. And then my C value is going to be my maximum minus the amplitude, or my minimum plus the amplitude, or I'm just going to do it by actually taking 15.135, adding the minimum 9.02 together to get 24 and change, and then divide that by 2 to find out what the average of the two numbers is, which is about 12.0775. Okay, barely fit on the paper, but I think we got it. So that's all there is to it. Find the amplitude, find the period, find the horizontal shift by the first peak, and then find the vertical shift in any number of ways that we talked about. Max minus amplitude, min plus amplitude, or the average of max and min, so add them together, divide by 2. Incidentally, sometimes the numbers that we get can give us a little bit of information about what these graphs represent. So for instance, you'll notice that neither of these has the vertical or horizontal axes labeled. It doesn't tell you if this is, water versus like water height versus something. It doesn't tell you if it's sunlight or whatever. But the fact that that the period here is 12 might suggest that it's something that repeats twice a day, every 24 hours. Maybe that's tidal. Maybe that's just the height of tides because there's 2 tides every day. Likewise over here, this seems like a weird number, 366. My guess is it's probably very close to 365. So it's something that's changing annually. So it's something that's going up and down over a year. So it might be the amount of sunlight we get in a year. It might be the average temperature every day for a year or something like that. You don't have to worry about that right now. I just thought I'd point out that sometimes looking at the period gives little hints about what it is that it's actually representing. If the period is 7, it's probably something that repeats every week, and so on. Okay, so for your practice problems, you've got a few graphs here. Go through, see if you can find the equations for them. I put them down there, but truth be told, I probably didn't need to. When you think you've got your model, throw it into Desmos and see what it looks like. And if it looks like it's the graph that you started with, you probably came up with the right equation for it. And if not, you probably did not. Anyway, give those a shot and let me know if I can help you out at all. And I will see you in the next lesson.